Welcome back, everybody, to yet another recording in the topic of Python, with a focus now on lists. This is for CSCI-150, which you probably already know by now, and the expectation is that you've done the assigned readings and exercises before doing this recording, or before watching this recording. So the major topic here is list, and you should have seen that by now. For example, one place where you've seen list is with strings. We could do something like, for example, let's do str equals to, this is my name, okay, and I could say str.split. That would return a string, not a string, a list of values, I, M, and R, that are separated without the separators. This is a list. Values in the list are accessed by their location. So I'm going to do the same thing here. I'm going to say for LST is equal to this. Okay, and every time I say LST, I get all three values. But if I want to access a specific list location, I have to provide an index or a position or a location in square brackets. So if I say 0, I'll get the first element. If I say 1, I'll get the second element. And if I say 2, I get the third element. Of course, if you try to do anything more than that, then you'll get index out of bounds. So this is in general a brief introduction to lists. What we're going to see here is we're going to see an example of working with parallel lists, which are two different lists. Like in this case, I've got the list of scores and the list of students, such that the locations are important, in that the first score is for the first student here, the second score is for the second student here, third score is for the third student here, and so on and so forth. So these lists are known as parallel lists, which means the location of one, the values at a specific location on one list belong to the same thing, person, object, whatever you want to call it, as all the values at the same location in other lists. Some important, so I'm going to copy these and run them quickly over here. So these are the two lists. I'm printing the length of the list. I've got 9 students took the midterm. These are the scores for the midterm. Let's just assume that. And then I'm computing the average, where I take the sum of the scores and divide by the length of the scores. Sum is a function. You could give it a list, and it'll add up all the numbers in your list if they happen to be numbers, of course. One important operator that is often used with list is the in operator, and it's used in a situation where if you want to find a value in a list. For example, I can say, is 90 in scores? It'll tell me false. Is let's put one now that actually exists. Is 100, or let's say 76 in the list? It tells me true. So in general, if you have a value variable, let's say has the value 58.5, and you say the condition, if value in scores, this will evaluate it through if the value is actually in the list. So in this particular case, 58.5 does exist. So what's going to happen is you're going to go to the if part of the condition. And the index function is very similar to the find method in strings. It tells you the location or the index of where that value exists in the list. This is important if you have parallel lists, because that's how I'm able to get the name of that person. So I'm gonna run this part over here. 58.5 is in score, so it's gonna go and run this method over here. It's gonna try to find the location of value in scores, and it's gonna give me location 3 starting at 0. So 0, 1, 2, 3, that's where it exists. And now the index of value, if I use it as an index for scores, it's going to give me the 4th score. And if I use it on the student list, it's going to give me the student lead. It's going to tell me that basically 58.5 is in list. At location 3, it was scored by Lee. So that's how parallel lists always work. You're going to use the same index to access the values that belong to the same object. Of course, if I were to do the same thing now, but try a value that doesn't exist, it's going to tell me that the value does not exist. One thing to keep in mind, though, that if you try to use the index function on a value that does not exist, unlike the find method that returns -1 for strings, this one returns an error. So let's say I look for the value 4,444. It's going to tell me it's not on the list, but it's going to throw an error, which is why it's very important that you test that the value is in the list before you try to get the index. Looping over the values in a list is very straightforward. You do something like this. Okay, so for scoring scores, print, and then you are basically printing all the values. It's going to do that. This is great, but one of the problems is if you try to loop like this without using an index, it becomes problematic when you're dealing with parallel lists, because with parallel lists, you need to access the locations at the same index in both lists, and that is not possible with a list like this. So we have to use an index as part of our list, as part of our loop. So this is the first exercise. We want to loop over all the values in the two lists and then display every student with their score at their location. So it should say score at index 0 is 99.5, and this is for student Ellie. Score at location 1 is 78.25 for student Jen, and so on and so forth. So I'm going to have a variable called position. You could call it index, you could call it location, you could call it position, whatever you want. And position is going to start at 0 and then go all the way as long as we have not reached the end of the list. So it has not exceeded the length of my list, which is called scores. As long as I have not reached the end, I want to display the index, which is in this case position. So the first entry of the first variable over here will be the position variable. The second one will be the score. So that would be scores at position. And then the last one would be student at position. Student at position. So get the position, find the score at that position, and then find the student at that position. And then we should not forget to increment our variable by 1. So position would be position plus 1. And by now you know that a shorthand way to achieve the same thing is to write it like this. So that basically increases position by 1. And we're going to run this part now. Let's do that here. Scores is not defined. I need to put this. I reset the program, which is why we're getting this error. So we should be good now. Students. Okay, try one more time. Okay, so now it's basically going over the list. First position is 0. 0 is less than 9, the length. It's going to print score at index 0 is score of 0, which is 99.5, students of 0, which is Ellie. Position is going to become 1. It's going to go back over here. 1 is still less than the length, which is 9. Print score at index 1 is 78.25, which is the second score of my list, followed by the name of the student, which is Jen, and so on and so forth. The second exercise, we're going to do the same exact thing, but now using a for loop that loops over the position. So we're going to achieve the same exact thing, but using the for loop instead. So I'm going to copy that over here. Okay. And, you know, when you're going from a while loop to a for loop, the initialization, the condition, and the incrementation become part of the for loop statement. So in this case, for position in range, 0 to length of scores. Okay, what I want to do is I want to print position, scores at position, and then student at position. So it's actually the same print statement from before. Nothing changes over here. Okay, and then we're getting exactly the same thing. The last exercise asks you to enter a new student name and a new score for them to add it to the list. Okay, so if you enter a new name, let's say Imad, and score of 50 at the end, after Benny, Imad is appended, and then the score for Imad would be 50 at the end of the string. But that is only if the name is a new student name. If on the other hand I enter, for example, Jen, and then give Jen a new score, I don't want to append Jen to the end. I want to update her score to the new score. So here's that part. First, I want to check if the new name is already in student. So if new name is in student, okay, I want to update as opposed to append. So if new student not in students, if it's not in student, then what I'm gonna do is I'm gonna take the students and then use the append method to add the new student to the end. And then the same thing, I'm going to take the scores and I'm going to append the new score to the very end. Else, I know that this is not a new student. This is a student that I've seen before. So the first thing is I want to know where it exists in the list so that I can find its grade and update it. So I'm going to say index of student would be, since I know it is in my list, would be students.index, and then find the location of new student. Okay, and then once you do that, go to that location in the scores list. So index of student, and then update that to be the new score. Oops, apologize for the many typos in here. Score, new score. Okay, so let's take that and see what we get. Okay. So it's going to ask me to enter a name. I'm going to enter a name that doesn't exist. Let's say Mike. We don't have a Mike. Not Mike, Mike. And we're going to give Mike 55.99. Okay. Notice that now Mike is at the end. It's been appended to the end. And his score is 59.99 at the end. On the other hand, if I run the same piece of code now and say, let's take Ben, the third score, and I want to, instead of 76, I want to make Ben's score 96.5. Okay, notice that now Ellie, Jen, Ben, now Ben has a score of 96.5. You should take the time to study the code carefully in order to understand how that was accomplished. But for now, that should be the end of this recording. Thank you much for listening so far.